So here's a classic exam style question. I've taken it from the book. Find the range of values for k for which x squared plus k plus 1x plus 1 has real roots. So we know a quadratic equation has real roots in this discriminant case, as long as b squared minus 4ac is greater than or equal to 0. You may remember that there was three cases. There was like one real root, two real roots, or imaginary roots. So when it was equal to 0, it meant it had one repeated root. When it was greater than 0, but that repeated root was real. But when it was greater than 0, it had two real roots, but they were distinct. They were different real roots. But then when it was less than 0, you were talking about imaginary roots. But for us, it just wants real roots. So that's like the two cases combined, when it's greater than 0 and when it's equal to 0. Because equal to 0, it's still a real root even though it's repeated. So that was graphs that like sat on the x-axis, say. But anyway, this is the case for just standard real roots, right? As long as b squared minus 4ac, which is the discriminant, that's the part under the square root in the minus b formula. So let's look at what we can replace for b, a, and c in this equation. Well, remember, our a is always our coefficient with our x squared. So here, our a is going to be equal to 1. Our b is always our coefficient with our x, which here is k plus 1. And our c is always the constant out here on its own, which is 1. So this would mean that for those, our actual equation that we're going to form is this b squared minus 4ac greater than or equal to 0. So b squared, what's that? In our case, that's k plus 1 squared minus 4 times a, that's 4 times 1 for us, and times c, which is also 1 for us. And that has to be greater than or equal to 0. Okay? So let's actually square this stuff out here. It's an equation in k quadratic, alright? So it's k squared plus 2k plus 1 minus 4 times 1, 1. So that's just 4. Greater than or equal to 0. Okay, let's tidy this up a little bit. That's k squared plus 2k plus 1 minus 4. That's a minus 3 greater than or equal to 0. Okay, so this is a quadratic equation. It's a U-shaped graph because it's a positive quadratic. So let's kind of draw a quick sketch here of what we're dealing with. So something like this, right? Now, what we are looking at here is, where is this graph in k actually above greater than or equal to 0? So greater than or equal to 0 is actually everything above the y-axis. Is all this stuff here. This is greater than 0, and this stuff here. So like greater than the y is equal to 0 line. Okay? So what are all these values that give us that back? Well, it's all these values here. Because once this graph gets bigger, it keeps going off to the left. Once it gets bigger here, it keeps going off to the right, and all these values here. So if we could find these points here, we could tell you that less than this point is all greater than 0, and right at this point is all 0. And of course, we know these 2 points to be the roots. Okay, so let's solve this for the roots. So let's factorize it. So this is pretty simple, isn't it? So k is either equal to minus 3 or k is equal to 1. So these must be the 2 roots. This must be minus 3 here. This must be 1. So we can definitively say here that as long as k, and remember, like, even though this is the x-axis, I've drawn that just for, that's what you're familiar with. We're talking about k values along here. So as long as the k value is lower than 3 and bigger than 1, we're good. How would you write that? Well, k must be less than or equal to minus 3, and also k must be greater than or equal to 1. So that's our solution. And to write that then as a inequality, you could actually like leave it like that, but you might write it to like it. I usually start with k in the middle, and so let's write it like this. So k, and I usually put the larger value, which is 1 in this case, to the right hand side. So this would be in the 1 inequality, and now less than minus 3 we can actually write like this. So you don't often see them written like that, but that's a good answer for you. So that value's for k sorted. So we've taken something from a discriminant case from like Algebra 1 or 2, and we've brought into this Algebra 3 world, and this type of question is something you should really be familiar with. It's a real leaving cert style question, like off paper 1, question 1 or 2 or something like that.